Hi everyone, welcome to Vedantu J English. I'm Diksha Kaushal, your chemistry master teacher. So everybody, do let me know in the chat box if I am clearly visible and audible to all of you or not. And yes, everybody in the chat box, yes, I can see your replies over here. Right, wait a minute. So, yes students, yes everybody, visible, audible. Yes, everyone. Hello, Lokesh, Sai, Prem, Lata, Suhas, Vishwa, Ramya, Phantom, Supriya, Sai. How are you all? How are you all? So finally the wait is over and we are at one of the most important chapters, that is chemical bonding, right? Now this chapter, without this organic chemistry is actually what we talk about chemistry. Whenever we talk about chemistry, we talk about bond formations, right? So if you don't know how that bond is formed, then how will you be able to understand the full chemistry, right? So that's why this chemical bonding part, not only here, you will see this everywhere, right? Everywhere. So that's why very important. First thing is direct questions are asked, predictable questions are asked, right? It's not like out of somewhere they will ask you the question. No, if you have done this chapter, most probably, right, you must have done that question also, right? And in inorganic chemistry, usually we talk about cramming, so many exceptions, but in this chapter, right, we have theories and we have to learn, like we learned about structure of atom, we learned about different theories. Similar way we are going to talk about theories over here, right? No, there is no prerequisite, but what you need to do before chemical bonding is structure of atom, electronic configuration, that much I expect. And you should know little knowledge of periodic table also should be there, right? Not like full periodic table you should be able to, like, you should be able to tell me that this element is placed here in the periodic table. That I am not asking. Just simple that first 20 elements, 20 to 30 elements, what are these elements? These simple things you should know, right? So how does the chapter goes? First we will talk about bonds, we'll talk about type of bonds, then we will talk about octet rule, Born-Haber cycle, Lewis dot structure. It is dot structure, it's not dot structure, it's dot structures, and Fajan's rule, right? So these are the major topics and all the topics are very important for you, right? Okay. In this chapter, if you ask me, ma'am, which is the most important topic in this chapter, every single topic is important because from every single topic the questions are asked here, right? Okay, yes. So ready for the class? If you guys are ready for the class, then spam the chat box with the green hearts. Everybody, if you're ready for the class, then spam the chat box with green hearts. Yes, guys. Yes, students, spam the chat box with green hearts if you're ready for the class. Okay, so let's firstly understand why we need to study this, right? So one daily life example is, tell me one thing. Are you able to melt a salt? You have 1 cup of salt. Are you able to melt it? But you can melt sugar, right? Sugar you can melt, but salt you cannot melt. Now what is the reason why you can melt sugar but you can't melt salt? The reason is because the difference in their bonding, right? Because in salt you have ionic bonds, and ionic bonds are difficult to break, right, as compared to bonds in sugar that are covalent bonds, right? So covalent bonds are still easy to break as compared to ionic bonds. So that's why when you melt it, covalent bond, that means sugar can be melted easily but salt cannot be melted. So this is an example from your daily life. And I usually in fact, if someone asks you, you study science, right, but where science is in your daily life, so these examples you can give, that science how it is in your daily life, right? Now When I talk about bonds, right, salt and sugar have different bonds, okay. I talked about ionic, I talked about covalent. So ma'am, first thing is, ma'am, what is this bond, ma'am? You're talking about bond. What is this bond? So bond is the attractive force holds various constituents, atoms, ions, etc. together in a different chemical species, that is called a chemical bond, right? So like you and your sister, okay? You guys, no matter how much you fight, you guys love each other, isn't it? Do you love your sister or not? No matter, you will like fight like 1,000 times in a day with your sibling, not sister, your brother, anyone, right? But the bond that you have is very strong, right? So like there is some relation that we have with every person that we meet. Some are our friends, there are parents, right? Then our cousins, right? Some are best friends, right? So different bonds you share with different people, right? But these bonds are the reason that you can say that, yes, when you introduce, you say, this is my friend, this is my best friend, this is my sister, this is my brother. You name that something, right? So similarly, when atoms are bonded with each other, they are in, like, they have some relationship with each other, right? So like you have brother, sister, cousin, right? Boyfriend, girlfriend, these kind of relations that you have, you name it something, right? There should be some name of that relation, right? So similarly, chemical bonds also have names, right? So chemical bonds are also divided into two parts. Like we know that in our daily life, some bonds are very strong, some bonds are very weak, right? So some bonds are like, you will be like, hey, this is my best friend, right? He'll be there. If I ask him that, let's jump off the roof, he will do that with me without even asking, right? Then there is your friend, right, who is not so, like, not a very good friend. You'll be like, yeah, he is a friend, he is a known, but not that of a good friend that I'll share everything with them, right? So that means you, in your life also, you're defining strong bonds and weak bonds. You also have that definition, you also have that differentiation. Similarly, atoms have that differentiation, right? So atoms are like, you will have strong bonds, right? And you will have weak bonds. Both the bonds you will have. You will have strong bonds also, and you will have weak bond also. So when you talk about strong bonds, that means we are talking about actually ionic bond. Wait a minute. Yes, let me just show you that here. We are talking about ionic bond, covalent bond, coordinate bond, metallic bond. These are strong bonds under the category of strong bonds. Then when we talk about weak bonds, then we have hydrogen bond and van der Waals forces. These are under the category of weak bonds, right? Now you will ask me, ma'am, what are these strong bonds, ma'am? What do you mean by these strong bonds, right? So first thing is, I'll just conclude ionic, see, ionic, covalent, coordinate, metallic, no matter how many times you have done the same thing, right? So that basic things I'm not going to tell you again and again, and you know, because I know that you already know that. Achha, tell me, if I talk about ionic bond, if two atoms, they have ionic bond with each other, they will transfer the electron. For example, it will transfer, the A will lose the electron and become A positive, B will gain the electron and become B negative. So in ionic bond, there is transfer of electron. That is an ionic bond. In a covalent bond, you will have A and B and they will share an electron. For example, A has electron which I am mentioning by this pink color, and B has electron which I am mentioning by this blue color, right? So there is a bond formation where it's not like A is like, I am such a, saint, I have, given you all my electrons, take this electrons and go. And B is like, oh, one electron I'll take. No. In covalent, there is sharing of electron. It's not like someone is very poor, someone is very rich. In ionic bond, it's like Rich person is giving money to the poor person, donating, full donation is there. In covalent bond, it's like you and your friend are living in a, let's say in a hostel, right? Or you're living, you're living in some rental room, right? So in that rental room, it's not like your friend is giving all the money, you are giving all the money, you are sharing that. 50% you are giving, 50% your friend is giving. That is called covalent bond, right? Where you are sharing the electrons. Now tell me one thing, if your best friend would be there, with your best friend, you would be like, okay, you want to take this money, take that. For your best friend, you would also have given up that money for them, right? But for your so-so friend, you'll be like, I can share. You give 50%, I give 50%. Whenever we go out with our best friend, we don't have to worry about it. We're like, today you give the money, today you give the money. We are completely transferring the money, right? So that means when you're transferring something, your bond has to be stronger. When you're sharing something, it's okay, right? With a like common friend also, we can share 50% of rent, right? That we can do, right? So that's why ionic bond is stronger as compared to covalent bond. If you talk about chemistry perspective, because the ionic bond has electrostatic interactions, that's why it is stronger. Then covalent bond, let's talk about covalent bond. Covalent bond is of next level. Covalent bond is where A is very rich, A has 2 extra electrons, let's say A has 2 extra electrons. Now E is having 2 extra electrons, but it's not exactly extra. It's like you have bought a pizza, right? And your friend is also very hungry. He has not bought anything for lunch, right? So you are not like, hey, I'll give my pizza to you. He will not do that. He'll be like, I'll keep my pizza to myself also. You can have just one slice from this. He's sharing, but not completely sharing, right? So similarly, in this, what will happen? In the coordinate bond, one atom will be rich, right? And that atom is going to share those 2 electrons. In a covalent bond, the 2 electrons, one belongs to one atom, other belongs to other atom, right? Those 2 electrons, these 2 electrons belong to different atoms. But in a coordinate bond, these 2 electrons will belong to only one atom here. That is the difference in coordinate and covalent bond, right? Now guys, let's talk about metallic bond. So metallic bond is like you have a metal, right? This we have studied so many times. In physics also you must have studied this, right? That this is, these are the kernels where these atoms are attached and electrons are flowing here. Electrons are flowing here, right? So the bond that you have, the bond that metal atoms carry with each other, that is the metallic bond. Now, for coordinate bond, we have studied coordination chemistry. If you talk about for the coordinate bond, we have already studied coordination chemistry. Our focus is entirely in this lecture, in today's lecture, is going to be on ionic bond, then on coordinate, then on covalent bond. Metallic bond also we will not study, coordinate bond also we will not study in this particular chapter, right? Okay. So majorly our focus in today's lecture is going to be ionic bond, and then we will slightly shift towards covalent bond. Right everybody? Right everybody? Is that clear to everyone? Right? Everyone? Clear? So, now let's move to the next part. Now we discuss about how many types of bonds you have. Weak bonds, no? Hydrogen bond and van der Waals forces. This I'll tell you. If you talk about hydrogen bonding, right, that we will study in the end of this chapter. We'll study about, in detail, we'll study about hydrogen bonding. And van der Waals interactions, I'll tell you. Van der Waals interactions are basically For example, two molecules, let's say this is one molecule of HCl, this is other molecule of HCl. The interactions that they carry with each other, there is no share of electron or transfer of electron, nothing is there. It's just attraction between two molecules or two atoms without any sharing or transfer of electrons. That is called van der Waals forces, and they are very weak forces, right? Even weaker than hydrogen bonding, right? Okay, so that we'll talk about later on in this chapter. Now let's understand, yes ma'am, you have told us about types of chemical bonds. Strong bonds there are, weak bonds there are. But the question is, why they need to form the bond? What is the need to form the bond, right? Why this hydrogen needs to make a bond with chlorine? Why it is so? See, now if you talk about why everyone can't be a brahmachari, that why everyone can't be a single person, right? We all are like, okay, this is Chintu and he will saw Anita, right? He will saw Anita, he will get attracted towards Anita. Anita will get attracted towards Chintu, and that is the reason, right, that we make bonds, right? So that is the reason, right, our word is going, right? Then we get married, then we get, then we are like, okay, then we have our kids, then again they will find someone, then again they will get married, and then again they will have kids. This circle goes on, right? So there is some reason, right? Because we need emotional support, right? Like we need someone who can listen to our buck every time. But what about these atoms? Do they also buck? Do they also need someone to listen to them? Why hydrogen is feeling lonely or what? Why hydrogen needs to make a bond with chlorine? What is the reason? So there are two approaches towards it, right? So the first approach is classical approach, second approach is the modern approach. Okay, so two kind of approaches you have for why they have to make a bond, right? So first approach is a classical approach. Now guys, the chapter has started. From here till before I was talking about only very simple things, but now the chapter has started, right? Okay. It's an ionic bond. It's an ionic bond. I'm transferring my knowledge to you, no? I'm transferring my knowledge to you. So the bond that we guys share, we are ionic bond, right? Okay, Ujjwal. So now see this. Classical approach and modern approach, these are the two approaches that we have. Classical approach is that we simply say that in this classical approach, what we talk about, that why they are making bond? Because they need to complete their octet. Because they need to complete their octet or duplet for, and duplet is formed by hydrogen or helium. Rest of them wants to complete their octet. Now octet means they want to have 8 electrons in outermost shell. They want to have 8 electrons in the outermost shell. That is the first approach, right? And today we are going to focus on this approach, that is octet approach. And rest of the chapter is on the basis of modern approach, that is based on the energy. That more is the energy, less is the stability, right? And in this we will study about VBT. First we will study Vesper, then we will study VBT, right? We will study MOT. All these things are based on energy, right? So all the other theories are the theories of modern approach, right? But modern approach we are not going to study today, that we have different lectures for that. Next 3 lectures are totally going to dedicated to modern approach. Today our task is to understand this octet rule, right? And with this octet rule we'll study Lewis dot structure, everything we'll study about this, right? So classical approach is octet rule and modern approach is related to this energy. Now don't get confused by looking at this diagram, that I'll tell you when we'll study VBT, right? This diagram is based on, can you see, energy and distance. So modern approach is entirely based on the energy, right? So that's why as of now we don't need to study this. Now let's understand classical approach, that is octet rule, in detail. Okay guys, everybody ready for classical or the octet rule, right? Because it's very important. Here we are going to discuss about Lewis dot structure, all the things, right? Lewis dot structure, how it is formed, how to calculate formal charge, right? All the things, the limitations are also very important here, right? So all the things we are going to do in octet rule, and it's next 30-40 minutes we are going to discuss this thing only. So everybody ready? And trust me, most of the students don't know how to draw Lewis dot structure, right? So I'll give you a simple trick on how to draw Lewis dot structure. We'll also do some very good examples for that, right? So let's understand. When we talk about octet rule, right, the first thing is, for an octet rule, wait a minute, okay, let's talk about this. I just want that nothing should be left. So according to Lewis, this was given by Lewis, right, that's why it is Lewis dot structure. So Costello-Lewis approach, any atom tries to complete its octet. Every atom, so atom, what they are trying to do, they are like, I want to complete my octet, let me complete my octet, I'll be in a more stable situation. Now the question may be, but ma'am, why they want to complete their octet, right? Isn't it this question that is in everyone's head? Why they want to complete octet? What is the reason? Why they want to complete octet? The reason is that, first thing is, when you talk about octet, they will have 8 electrons, right? And why 8 electrons are needed here? Because if you see all the noble gases, they are stable. Okay, tell me one thing, why you want to get rich? Tell me one thing guys, why you want to get rich? Why you want to get rich? Because ma'am, I'll cry, ma'am. When I get rich, ma'am, I'll cry. No. Because when you see Ambani, you're like, Ambani, what a life, right? You don't have to think about money, right? Why we want to get rich? We want to get rich because we know that after becoming rich, life will be easy. That's the, see, we don't know it will become easy or not. Even I'm not that rich, right? Even I just want, when I see people, I'm like, yeah, this is a good business, bro, right? You are rich, huh? Very nice. You don't have to worry about your salary, your job, anything. We have to worry about everything, huh? So when we look for like these business people, we like, wow, yeah, they are earning like in literally in lakhs and crores. Wow, we want to be stable. I don't know whether they are happy in their life or not. I just know, okay, Ambani, very stable. Okay, I want to be that, right? Maybe Ambani is thinking, what this money I would do with this money? Nothing this is, right? I'm bored of my life, right? Maybe Ambani is thinking like that. So why, when we look at someone, right, who we think is very stable, we're like, I want to become that person. Similarly, scientists thought about noble gases. They are like, noble gases, very stable. Noble gases are not like, I want to make a bond, I want to make a bond. Noble gases are very stable. So they're like, maybe these atoms want to become noble gases. These atoms want to become that much rich. That's why they are working so hard. That's why they're losing the atom, losing the electrons, gaining the electron. And these things tell us that they want, when they see noble gases, they are like, noble gases are noble gases because they have 8 electrons. Only helium has 2 electrons, other gases have 8 electrons. So they want to achieve the octet configuration because their ideal person is noble gases. This is the theory that scientists have put as of now. This theory will fail, but as of now everyone is thinking because they want to become noble gases, and that's why They are ready to lose electron, they are ready to gain electron, they are okay with everything. They just want to become noble gases. That is the reason. Okay, that is the reason. Got it? No? Right? Don't worry, beta. Chemical bonding is advanced level only. Don't worry. Right? This will touch that, but very slowly we'll go about it. But you know, these 4 lectures are going to be for theory and questions. But I'm going to take up on next Monday or next week, I'll take up 1 lecture which is based on JEE advanced questions. Okay, now I'll do this thing only. I'll complete 1 theory chapter, then I'll do advanced question also based on that. Right? So don't worry about that. So, very good IITian. Very good. What a beautiful thing he has written, ma'am. What about xenon, ma'am? Xenon is making bonds. That will become the limitation of this theory. See, IITian has, that's why he is IITian, right? That's why the name is IITian, right? So that will become the limitation of this theory. When we'll study the limitation, we'll study this exact point that you are saying they're not making any bonds, but noble gases make bonds. So that will become the limitation. That's why this theory will fail in the end, right? So as of now, scientists are not thinking about xenon, right? They are not, it was not even discovered at that point. So they are not thinking about that, right? So right now they are just focused on, according to Lewis, any atom tries to complete its octet, having 8 electrons in its valence shell, noble gas configuration by donating or accepting shared pair of electron. The only task is to do that, right? Okay. Yes, everybody. Now, if you see this thing here, now when you talk about Lewis dot structures, these dots are actually representing the number of valence electrons, right? For that, ma'am, we have to understand. Now, how many of you know what is the difference in valency and valence electrons? Valency and valence electrons. Let me see how many of you know the difference in valency and valence electrons. Valency and valence electrons. See guys, if I talk about oxygen, right, it is 1s2, 2s2, 2p4. Its oxygen atomic number is 8. And this is why structure of atom is important before starting chemical bonding, because electronic configuration you learn from structure of atom. Now guys, see, valency is valence electron is the number of electrons in outermost shell. In outermost shell. So this is the outermost shell. So here the valence electron in oxygen is going to be 6. Valence electrons are 6, but what is the valency? Valency is number of electron lost or gained. Number of electron lost or gained will be what? If in the outermost shell you have 6 electrons, how many electrons you need to gain to have 8 electrons in the outermost shell? I am talking about outermost shell. I am not talking about full electrons. Outermost shell, you need to gain 2 electrons to have octet rule, to complete the octet rule. So that means the valency is going to be 2, right? It is going to gain 2 electrons. That's why O2 negative is a very famous compound that exists. Okay, understood? Understood guys, the difference in valency and valence electrons. What is valency and what is valence electrons? So this is valency. If you talk about valency is number of electrons gained or lost to complete its, to have its octet configuration, and valence electron is in the outermost shell. That is the difference. That difference should be clear, right? Now let's talk about second period. Those who have done periodic classification, you know this is second period, isn't it? This is the second period. Now tell me guys one thing. If I talk about second period, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine. outermost electron. If I talk about the group here, this belongs to group 1, 2, then this is 13, 14, 15, 16, 17 and this is 18. Now if I talk about valency, firstly let's talk about valence electrons. Valence electrons are, let's talk about that. Valence electrons are, in lithium, you will have 1 valence electrons. In beryllium, you will have 2. In boron, it belongs to group number 13, you will have 3 valence electron, right? This I have already told you in periodic classification why it is so, right? So I am just gonna write it here, 1, 2, 3. This is 4, this is 5, this is 6, this is 7 and this is 10. Now without knowing the valence electron concept, you can't understand Lewis dot structure. In every formula you will see valence electron. So this should be in your brain that okay, if something is belonging to group 1, it is 1 valence electron, group 2, 2 valence electron, group 13, 3 valence electron, group 14, 4 valence electron, group 15, 5 valence electrons, group 16, 6 valence electron, group 17, 7 valence electrons, group 18, 8 valence electron. That should be in your head as clear as possible, right? Okay, now if I ask you group number 17, okay, not group number 17, tell me valence electrons in iodine, everybody in the chat box, valence electrons in iodine. Let's see how many of you are awake and how many of you are fooling your parents by just being on this live. Like, mom, I'm studying, mom, I'm studying. Diksha Ma'am is teaching, I'm studying, mom. And side by side, you are chatting with someone, right? Tell me, everybody. Very good. Very good. It belongs to group number 17, fluorine, chlorine, bromine, iodine, okay? Similarly, if they ask you sulfur, we know that sulfur, for this you need to have knowledge of periodic classification, right? So that's why guys, I have not done it like this. Firstly, I'll pick up GOC, then I'll pick up chemical bonding, then I'll teach you periodic classification. That's why the sequence I have properly maintained for you guys, right? Because I know that it's very tough if your basics are not clear, right? So sulfur belongs to group number 16. It will have 6, yes, it will have 6 valence electron because it belongs to group number 16, right? Okay, now some of you are also writing 4, okay? Let me see that. Valency. By the way, valency is not used in this chapter. Valency will not be of that much use to you, but still I am writing it just to clear that. See, group 1 will gain 1 electron, right? And group 2 will not gain any, it can lose 2 electrons, yes, it will, sorry. Group 1 will lose 1 electron, group 2 will lose 2 electron, group 3 will have to lose 3 electron, group 4 will share the electron, 4 electrons it will share. Group 5 will gain 3 electrons, it will gain 2 electrons, it will gain 1 electron and nothing will happen here. So here this will lose electron, this will share electron, right? Let me just write it here. This is going to gain electron. Okay? Okay, I'll just go to this side. Understood? So what we have done here, everybody, what we have done here. So group 1 will gain, will lose 1 electron, group 2 will always lose 2 electrons, group 13 will lose 3 electrons, group 4 carbon family will share, that's why they form covalent bonds. Then group 15 is going to gain 3 electrons, group 16 2 electrons, group 17 1 electrons, just to complete its outermost configuration. They all are doing this for their outermost configuration, nothing else. They all have this much greediness to have outermost configuration. Oops. Okay. I think that is done. Now I'll teach you something, some important rules here, right? Okay. Let me just show you that. Yes. So when you draw Lewis dot structure, 2-3 things you need to understand here. First is central metal atom. Which is going to be your central metal atom? The one that is less in number and size is large. And size is large. That is going to be your central metal atom. The one that is less in number and the size is large, that is central metal atom. Usually you will be able to understand central metal atom. Very difficult questions will not be asked to you, right? So that is done. Second is, this is a trick, okay? So I'll just write it here, oxygen. This is covalency. That means covalency means how many bonds they want to form, right? So let me just write it down, covalency. If you know this, if you know covalency, Lewis dot structure will become very easy for you. Firstly, I'm writing oxygen, then nitrogen, then sulfur, then phosphorus. I think that's it. Yes, carbon. These are some of the very famous compounds for which covalency you should know, right? Anybody who can tell me the covalency of this? Anybody? Guys, I can see Rohan, Aitian, Ujjwal. Yes, students. Adrit, Suhas, Naga, Anjali, Suhas. Yes. Very good. Guru. Yes. So if you talk about, we'll discuss that. Wait for some time, okay? So we'll discuss that, okay? So now oxygen, this chapter you need to have patience. 4 lectures I'll take for this chapter and every single lecture you have to attend. If you're not attending, even if you're missing 10 minutes of this lecture, the flow will break and next topic you won't be able to understand. So this chapter is going to give you marks definitely, right? So oxygen tries to form 2 bonds. Nitrogen happy in 3 bonds. Sulfur is very happy in 6 bonds. Phosphorus is happy in 3 or 5 bonds and carbon is happy in 4 bonds. Okay? So usually you will see these number of bonds on the, this is not, firstly one thing, this is not a part of Lewis dot theory. This is a trick that I am giving you. Trick means this knowledge you should have. If this knowledge you have, then Lewis dot structure will become very easy for you, right? If you're confused, if you don't know the covalency, then it will become very difficult for you, right? Okay. So otherwise, if you study Lewis dot structure from blank, then it will be very tough. But if you know these small points, then it will automatically become easy for you, right? Okay. Okay. I have one more important fact for you, right? Shall I tell you that? Everybody? Very important fact I have for you. Wait a minute. So, let me just, okay. So, it's a very important fact that is based on this only. If, tell me one thing, if number of bonds are more than expected, like you were expecting that number of bonds should be 2 and the number of bonds are 3, right? If the number of bonds are more than expected, then that atom will carry, which charge? Will carry. Tell me one thing, you were expecting I'll easily be able to crack NIT and you have cracked IIT. Now will you be happy or sad? Or you will be like, I got IIT, I'm so sad about it, ma'am. Ma'am, I got IIT, ma'am, I wanted NIT, ma'am. I got IIT, ma'am. Will you be sad about it? No, right? You'll be happy. You will be like, yes, I'm happy. So you'll carry positive charge. And if number of atoms, number of bonds are less than expected. You were expecting NIT and you got some private college, right, which is not giving very good placement, right? Now you'll be happy or not? Then you will carry which charge? Then you will carry a negative charge. You will feel sad about it. Atom will feel sad. Atom will carry negative charge. Atom will be like, I am very sad today. Why? Because I wanted NIT, I wanted IIT, I got, like you wanted IIT and you got NIT. It is still a good, very good college, but you will still feel like IIT, I wanted. For some days though you will feel negative, no? So you will feel negative, right? That's how you can remember. Now I'm going to start with 3 very simple structures. Then I'm going to start with complicated structure, but that I'll do with the help, some trick we will use for that. Right? Not even trick, it's actually a method. We will understand the steps for that. Firstly, let's draw for very simple 3 structures. I'm going to start here. Wait a minute. Yes. Okay. Yes, negative, very good. Okay. Now, 3 simple structures I'm going to draw here. First is for hydrogen, okay? First is for hydrogen. So, hydrogen has 1 electron. Let's say it has 1 electron here. Let's say another hydrogen has this. See, this atom, hydrogen, I am denoting it by this particular atom that you can see here, that I am denoting by this dot. And the other atom that you can see here, that I am denoting by this cross, right? So, here what I will do, I can also denote this by different these colors, because we have colors in our life, right? So, here what will happen, this hydrogen will share this electron and this other hydrogen will share this electron, and that's how they are making one bond, that is HH bond, right? That is a Lewis dot structure of H2. Similarly, let's talk about O2. For oxygen, you have 1s2, 2s2, 2p4. So, in the outermost shell, you have 6 electrons, and we only draw the valence electron, the outermost electrons, right? So, if I draw this here, if I mention this by oxygen, this is 1, 2, 3, 4, 5, 6. Another if I'm mentioning, let's say this by oxygen, this is 1, 2, 3, 4, 5, 6. Okay. Now, what I want to do, now I want to make a bond over here. So, this, to complete its octet, it will share this particular, these 2 electrons it will share, right? And this oxygen here will share these electrons. So, as you can see, these two oxygens that you can see are sharing 2 bonds here. Can you see they are sharing 2 bonds here? So, because they are sharing 2 bonds, this is first, this is second. So, as you can see, they are sharing 2 bonds. So, that is the reason we always have oxygen and oxygen, you have 2 bonds here. Okay? Got it? Got it, everybody? Beta, wait for some time. Right? Okay, so now let's talk about N2, right? Let's talk about N2. So this is nitrogen. Acha, tell me one thing. Do you have a smaller sibling, like some younger sibling or someone, right? Or niece, nephew, anyone? If they want to go to school, you want to admit them into the school. So, for their admission, will you directly put them in 11th class, 12th class, 9th class, 8th class? Will be like, ma'am, firstly, they will go to pre-nursery, then nursery, then first, second, third, fourth, fifth, sixth, seventh, eighth, ninth, 10th, right? Okay. So, have patience, right? So, directly, I can't tell you those big Lewis dot structure. You need to have patience, right, to understand that. So, now to understand N2, what we will do, we'll make nitrogen here. Nitrogen is nothing but it is 1s2, 2s2, 2p, 2p3. How many outermost electrons? 5. 5 valence electrons. So how do you draw it? Everyone, how do you draw it? Let's draw it. This is nitrogen. I'm drawing 1, 2, 3. I'll draw bigger one. Nitrogen 1, 2, 3, 4 and 5. Right? And here also I'll draw nitrogen 1, 2, 3, 4 and 5. Now to complete its octet, nitrogen is 5, so it needs to have 3 electrons. It needs to gain 3 electrons. So instead of gaining, it will share 3 electrons. It will try to have sharing of these 3 electrons with other nitrogen, and this nitrogen also will have sharing of other 3 electrons with the other nitrogen. So can you see these 2 nitrogens over here are right now in a sharing bond. So this nitrogen is making 3 bonds with the 2 lone pairs here, 1 lone pair on each nitrogen. That's why oxygen also you can see it will have 2 lone pairs, right? Why? Because here this lone pair and these are the unshared. These are unshared electrons. These are shared electrons, okay? If you see these that I have mentioned in blue, these are unshared electrons. And if I talk about these, this one and these 2 electrons, 1, 2, 3, 4, 1, 2, 3, 4, these electrons are your shared electrons. Okay? Chalo. Now, we have discussed this. Now, to understand all the structures that you are asking me to draw, yes, very good Adrit, it will form triple bond. Very good. Now, these structures are just to make you understand, just to get you familiar with these dots, right? But now, we'll make not Lewis dot structures, but we'll try to understand with the Lewis dot structure how to form the structures, right? Okay, everybody, now, most interesting part of today's lecture is going to start. So, are you all ready for that? Ready for beta? Ready for that, everybody? So let's talk about that. Lewis dot structures, right? For Lewis dot structure, there are some steps that you need to follow. Okay? Let's understand those steps here. So that is firstly what I'll have to do is firstly I will calculate the value of Q. Right, so 3 steps you will have in total. Just understand with 2-3 examples you will be able to understand this, right? So firstly let's go through the steps here. First is Q is equals to number of valence electrons, then in that number of valence electrons, if you have a negative charge in the molecule, you will add the negative charge, 1 charge, 2 charge, whatever is the charge, and you will subtract the positive charge if you have any positive charge. So I'll just write it like this. If you have any negative charge, that you will add, and if you have any positive charge, that you will subtract. Positive charge you are going to subtract. Okay? Positive charge is what you are going to subtract. Is that clear, everybody? Right? We'll also do questions based on this, right? Second step, I'm just writing it in theory. I know that most of you will not be able to understand what I'm writing, but I'm writing so that after when you check the notes, you can understand, right? But this particular thing that I'm writing, that I'm going to write, you can only understand with the help of these what I say, examples, right? So second is calculate number of bond pair electrons, or firstly make single bond single bond of each atom with the center metal atom. With center metal atom, each atom will have a sigma bond firstly. One bond it will make. Then sigma or pi we will talk about later in this chapter, right? Then in the third thing, what you will do? After that, what you will do? Calculate number of bond pair electrons, right? You have to calculate number of bond pair electrons. Fourth is calculate number of remaining electrons. Remaining electrons means valence electrons minus bond pair electrons. That is your remaining electron. Now these remaining electrons will be either lone pairs or they will be multiplicity. They will form the multiplicity. Either they will be in double or triple bond. Okay. So this is the thing that we are going to do. Either they will be in the double or triple bond, right? Or they will be the lone pairs. Okay. So this is a full-fledged concept, right? Okay. Don't worry, ma'am, number of bond pair depends on atom. Ma'am, what about lone pair? Yes. That's what I am telling you. With these steps, you won't be able to understand, right? You need examples for that. So let's firstly, steps I have already written. So I'll just delete this page, right? Let's draw the Lewis dot structure. First, I am drawing it for, let's draw for CO2. Okay, let's draw for CO2. Ready, everybody? Please keep your pen and notebook with you, right? And also do like the session, okay? Do like the session. Let me see how many likes you have made till now. Right? Make more likes, spread this lecture, because a lot of hard work we put into making sessions for you, right? So let's talk about CO2, okay? Okay, what is the first step? What is the first step here? Answering what is the value of Q. Let's understand what is this Q. Q is equals to number of valence electron of all the atoms. Carbon has valence electron 6. Carbon belongs to group number 14. It has, 4 valence electrons. Right? Okay. Wait a minute. Yes. Okay. So, carbon has valence electrons 4, oxygen has valence electron 6, and another oxygen has valence electron 6. So valence electrons is going to be, if I write here valence electrons, I'm just going to write, I'm going to take it very slowly, okay? Very slowly I'm taking it, because this is your first example, right? Valence electrons. Valence electron is 6 plus 6, 12 plus 4, that is 16. Right? 16 valence electron. Now what is the value of Q? Q is valence electrons plus or minus charge. So there is no charge on this, so no addition or subtraction here. So Q is 16 here, right? Plus 0 minus 0, that means it will be 16. Now what I'll do, I'll make this compound, right? But I'll make this compound with nothing. That means with nothing means this compound that I'm going to make, I'm just going to make it here. This compound I'm going to make here. Central metal atom, I have taken the one that is less in number, carbon. Carbon with oxygen and oxygen, because the next step was to make single bond of central metal atom with other atoms. So I have made the single bond, right? Now calculate the bond pair electrons. Now everybody calculate the bond pair electrons. So if I want to draw the bond pair electrons, if I say this is the structure that I have made, the bond pair electrons is going to be 1, 2, 3, 4. Okay, 1, 2, 3, 4. These are the bond pair electrons, right? On this, wait a minute. On this over here, this one, right? This one. I'm just guessing it. You have 1, 2, 3, 4 electrons. So it will be 4 electrons. Bond pair electrons are 4. If the number of bond pair electrons are 4, then what is going to be the remaining electrons? Remaining electrons, I'll call it as lone pair electrons, okay? I'll rather call it as lone pair electrons. Remaining electrons, you can say remaining electrons, whatever you want to say, right? Let's call it remaining. Let's call it R electrons. R electrons means remaining electrons. There is no such term, okay? I'm just writing it just for you. You can also write it lone pair electrons, right? Your choice. Remaining electrons are total valence electrons were 16. Out of that, when you subtract 4, it will be 12 electrons. Now, what you will do here, this is the compound that you have, okay? This is the compound that you have. In this compound, now what I'll do? See, in this compound, now what I'll do? I have how many electrons here? 12 electrons. These 12 electrons I need to put it here, right? So, how I will put it? Whenever you need to arrange the remaining electrons, you will firstly arrange it on the outer electrons. That means not the sentimental atom. So here you will arrange it like this, okay? So how do you arrange it? Firstly, this was single bond, no? So you will arrange it like this, 12, no? So 1, 2, 3, 4, 5, 6, 7, 8. You have to complete the octet. 1, 2, 3, 4, 5, 6, 7, 8. So that means 8 electrons are completed here, right? Now another 6 electrons you can arrange here, 1, 2, 3, 4, 5, 6, 7, 8. So another 8 electrons you have kept here. So octet is complete, right? And carbon has 1, 2, 3, 4. Carbon octet is not complete. The octet of carbon is not completed. And also oxygen, if octet of carbon is not completed, then what? Carbon will be like, I have only 4 electrons. I need electrons from you, oxygen. So oxygen will give its 2 electrons and make a bond here. This oxygen will also give its 2 electron and make a bond here, and that's how you have this structure of carbon dioxide, okay? Now why it's a linear structure, why it's not bent V structure, that is not there in this theory. So this theory, another limitation is it will not talk about shapes. It is only talking about bonds, right? So structure, because we know that its structure is linear, so I am writing it like that, right? Okay. Next is, let's talk about H3O positive. Now there is someone which has a positive charge, okay? Okay. Guys, please don't spam, right? So now if you have H3O, firstly you need to write the valence electrons. So now I'll speed it up. Valence electron is 3 from hydrogen, then 16, 6 from oxygen, so it is 6, 7, 8, 9 electrons. And the value of Q is nothing but that is valence electrons minus if there is any positive charge, right? So it will be 8, 8. So Q is going to be 8, right? Q is going to be 8, right? Okay. That means the electrons that you have here, now it is not valence electron, now the valence electrons are 8. Now you will take only Q in consideration, okay? Q, because otherwise you will get confused, okay? Just remember Q, we have 8. Now, let's draw a structure. Next part is, you have which one? Next part is, center metal atom is oxygen. Draw single bond with all the side atoms. Have we done that? Yes. Right, have we done that? Yes, we have drawn the single bond with the side electrons. Now calculate the bond pair electrons. If you calculate the bond pair electrons, that will come out to be 1, 1, 2, 3, 4, 5, 6. 6 electrons. So remaining electrons will become Q minus bond pair electrons, that is 2 electrons. So it's just 2 electrons that we are left with. So what I'll do here now, I'll just see how I can make this structure even better. So this one I'll delete, this one I'll delete. Now, what you will have here, you will have 2 electrons that you want to distribute. Hydrogen, you like, ma'am, give 2 electrons to hydrogen. Hydrogen can only occupy duplet. Already with single bond, hydrogen, each hydrogen's duplet is completed. So you can't give these 2 electrons to hydrogen. So you have to give this electron to oxygen. First, you will arrange the electrons in the on the side atoms. Then you will give these electrons to the center metal atom, right? Now, this is the structure. Can you see one thing? Oxygen is 1, 2, 3, 4, 5, 6, 7, 8. Hydrogen is 1. Hydrogen also, each hydrogen has 2 electrons. So everyone is very happy. But I am not happy. Why? Because I told you that oxygen tries to form 2 bonds. If it is more than expected, it will carry a positive charge. So that is the reason here you will have a positive charge. And this will become your structure. Okay? Right? Got it, everybody? Got it? So, next is, which one you are saying, ma'am? BF3. I'll do that. Firstly, I have more complicated things for you. Chalo, let's do BF3, okay? Let's do BF3. These are very simple that you are asking me, na? These are very simple structures, okay? Chalo, let's talk about BF3. Now, in this case, Q is going to be valence electrons of fluorine is 7, right? For fluorine, it is 7 into 3. For boron it is hydrogen, helium, lithium, beryllium, boron, right? So it is 1s2, 2s2, 2p1. So it has 3 valence electrons. So it will be 3. So 7, 21, 22, 23, 24. 24 electrons, and there is no charge here. So Q is 24, right? Now I have to make a structure here. You need to make a proper structure because till now we have no idea about shapes, okay? So I am making it like this because till now we have no idea about shapes. So randomly I am making it, right? So now, talking about the bond pairs here, tell me what are the bond pairs? Bond pair electrons are 1, 2, 3, 4, 5, 6. So 6 bond pair electrons you have. Remaining electrons will be how many? 24 minus 6, that is 18 electrons. Now always these 18 electrons will be here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Can you see it is already done? So that's why I am picking up difficult structures for you, right? Okay, this one is very easy. There is no complication of double bond, single bond, plus, minus, right? So that's why these structures, so you can do yourself also. Got it? Let's do those structures which you will find tough. Okay? Let's do those structures that you find tough. Got it, beta? Shall we do NH4 positive? Shall we do NH4 positive? Let's do that. NH4 positive, let's talk about nitrogen firstly. Let's talk about the Q value here. What is going to be the Q value? What is going to be the Q value? Let's see who can answer me this. What is going to be the value of Q? Yes. Manikaran, Adrit, I have seen your questions regarding XeOF4, right? XeOF4 is what you are asking me, right? So guys, that is under the limitation part, right? Okay, so that we will get to know about that, but for that first you will learn everything, then we will understand XeOF4, right? Okay, as of now, understand what I am teaching you. Okay, yes. So firstly, Q value is going to be number of electrons. Nitrogen is 7 valence electrons. and hydrogen is 4 valence electrons. Total valence electrons are this, and if there is any positive charge, that will be subtracted. So answer will be 7 plus 3, that is 10 electrons. So can I say 10 is going to be the correct answer? Is it? Is it, guys? Wait a minute, no 10, this is 15, yeah. 5 plus 4, that is 9, this will be 8. 8, 8, 8, 8, 8. Because nitrogen has 5 valence electrons, hydrogen has 4 valence electron, and out of that you have to subtract 1 because there is positive charge here. So that positive charge will be subtracted, right? Okay, very good. Now you have 8 electrons. Now what was the next step that we want to do? We need to make a single bond here. So let's make a single bond here. Let's make single bond. So single bond is between, this is nitrogen, this is, I am not drawing any shapes here, okay, I am just randomly drawing it because till Lewis dot we have no idea about shapes, right? So why to draw it? We are discussing the theory, right? So why to draw the shapes if we don't know till now? We will discuss about that later on in this chapter. Now this is the structure. We have drawn the single bonds. Now bond pair electron is 1, 2, 3, 4, 5, 6, 7, 8. So we'll draw 8 electrons. Remaining electron is 8 minus 8, that is 0. No electron is remaining. No electron, guys. No electron is remaining. Can you see? No electron is remaining. So simple thing is, ma'am, what we will do? What we will do? Now there is no electron that is remaining. All the electrons are there that we have filled. Now the next question is, ma'am, now shall we move ahead? No. I told you that nitrogen forms 3 bonds. If nitrogen here is forming 4 bonds, then it should have a positive here. So this positive charge is actually on the nitrogen. Okay? Yes, everybody? Okay, next structure is, let's draw NO3 negative, right? Let's draw NO3 negative. Okay, everyone? Let me see if my voice is clearly. Yes. Okay. So no lone pair. Yes, no lone pair, because nitrogen, if you see, nitrogen is actually, if it forms 3 hydrogens, it has 1 lone pair. But now with, if 1 more hydrogen is attached, it will donate this this particular bond to this one. It will donate its lone pair to hydrogen. Okay, it will share actually. So that is why it will be a positive charge. Okay, let's talk about NO. Let's talk about Q here. What is the value of Q, everybody? Valence electrons is 5 plus 8, this is 6 into 3 for oxygen, and if there is negative charge, you will add 1. So this is going to be 19 and 24, right? Yes, everybody? So now next step is to draw a simple single bond structure. So this is nitrogen with 1 oxygen, with other oxygen, with the 3rd oxygen. Simple single bond I have drawn, nothing else I have done, right? Now bond pair electrons is going to be what? It is going to be 1, 2, 3, 4, 5, 6. So 6 bond pair electrons, and remaining electrons is going to be 24 minus 6, that is 18 electrons here, right? That means 18 electrons you have to shift somewhere. These 18 electrons is what you have to fill now. Let's talk about these 18 electrons, okay? Now tell me, should I give these 18 electrons directly to nitrogen? No. Firstly, I'll give it to the side atoms to complete their octet. So it is 1, 2, 3, 4, 5, 6 and 7, 8. So this oxygen has octet. 1, 2, 3, 4, 5, 6, 7, 8. So it has octet. So out of 18, I have given 12 electrons. So 1, 2, 3, 4, 5, 6, 7, 8. So this oxygen also, octet is completed. So all the 18 electron I have distributed. Now is the structure done? Is the structure done? No. Why the structure is not done? For nitrogen it is 1, 2, 3, 4, 5, 6. Nitrogen is like, I also need to complete my octet. What you're doing with me? So some oxygen will help. Okay. So any oxygen you can say that will help. I'm assuming this oxygen is helping. So it is going to make a double bond here. So double bond is formed. Now if you see nitrogen 1, 2, 3, 4, 5, 6, 7, 8, nitrogen is also very happy now, right? Now wait a minute. Wait a minute. Yes. Okay. Now if you see this here, which pen should I use? This is a very important point, because there will be a coordinate bond formation. Okay, we'll see that. Now if you see this here, till now all the lone pairs are happy. Let's see. Oxygen wants to form double bond, oxygen is happy. This oxygen wants to form double bond. It is forming only single bond, so it will have a negative charge. This oxygen wanted to form double bond. This is having only one bond, so it will also have a negative charge. This nitrogen, if you see, nitrogen wanted to have a 3 bonds. It is having 4 bonds, so nitrogen will have positive charge. And this is the overall structure, okay, with all the positive and negatives here. Okay, yes everybody, right? Got it or not? No, nitrogen is forming one bond extra than what is expected from nitrogen. I told you, when you get more marks and what is expected from you, you will have positive. When you get less marks and what is expected from you, then you will have negative. Because oxygen is having less than what is expected, that's why it is negative. Okay? Okay, right? Got it. Adhir, these structures will do later on, right? Once we do VBT, these structures also we are going to do, right? Okay. Now, let's say there is, because there are so many limitations of this octet theory, and these structures we won't be able to draw from this theory, okay? Because this theory has limitations, right? Let's talk about the next one, that is O3. So if you talk about O3, Q is nothing but it is 6 into 3, that is 18 electrons. If you draw the value of Q here, value of this, if you draw the structure here, it will become O, 1, 2, okay? Right, that's how I am drawing the structure. And you know what? Feel like, ma'am, why you're drawing it in a shape? We can also draw it like this. Okay, your choice. Now tell me about the bond pair electrons. Bond pair electrons are 1, 2, 3, 4. It is 4. Remaining electrons are 18 minus 4, that is 14. So 14 electrons, you still have to draw these 14 electrons, guys. 14 electrons you still have to draw. Let's draw that. 14 electrons you still have to draw. Okay. So when you draw this, this is going to be, first you will give it to outermost, so it will be 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Till now you have completed 12 electrons, and 2 electrons you will give it to this one, isn't it? 2 electrons you will give it to this one. Now 6 plus 6, 12, 13, 14, 14 electrons you have distributed. But this distribution, we are not satisfied with this distribution. Why? Because if you see, this oxygen is not happy. This oxygen, like I have 1, 2, 3, 4, 5, 6 electrons. I need 2 more electrons. So this oxygen is going to take help from this oxygen. So it will form a double bond here, right? So what will happen here? Any oxygen can help. So this oxygen is helping and they are making a double bond. Now this oxygen is happy, this is happy. This oxygen is making 1, 2, 3, 4, 5, 6, 7, 8 bonds, happy. This oxygen is also very happy, 1, 2, 3, 4, 5, 6, 7, 8, 8 bonds. This oxygen is also very happy. They are very happy in their life. But this oxygen here, my friends, this is not happy. He's like, I have octet, but I wanted to form 2 bonds. I am only able to form 1 bond. So that's the reason it will adapt a negative charge here, right? So that's why here you will have negative. These 2 extra lone pairs means that it will have negative. Otherwise, oxygen always have 2 lone pairs only. Now this oxygen here is very positive. Why? Because it wanted to form 2 bonds. It is forming 3 bonds. So this will have a positive charge here. You know how you can draw it? Like this you can write, just to maintain that symmetry, right? And this is the structure of ozone that you have, okay? Thank you so much, Sai. Thank you so much. Thank you so much. So, great, done. Okay, now let's draw a structure of HNO3. This is the last structure that I am drawing because so many other things also we have to do. Just give me a second, guys. Just give me a second. This AC is going to kill me otherwise. Just give me a second, okay? Okay, everyone. Yes. So let's draw the structure of let's see Q is 24 or not. Let's see that. Q is number of valence electrons, that is 1 plus 5 plus 6 is 18. There is no charge here, so addition and minus will not be there. So 18 plus 6 is 24. Absolutely, you are right, Anjali. It is 24 electrons, right? Okay. Very good. Now, if you see this here, let's draw the single bonds, right? So when you draw the single bonds, nitrogen is center metal atom will be less in number, large in size and electronegative, okay? So nitrogen is falling into that category, right? Okay. So you will say, ma'am, oxygen is more electronegative, but less number of atoms are for nitrogen and hydrogen. And out of nitrogen and hydrogen, nitrogen is more electronegative, okay? Now you have here nitrogen. This will have 1 oxygen, 1 OH, and this will have 1 more oxygen, because hydrogen directly, see, if you like, ma'am, please draw it like this, ma'am, please draw it like this, 1 oxygen, 1 hydrogen. There is no such compound that exists like that, okay? So this, yes, little bit knowledge also should be there, right? So this is how you will draw it. Now if you see, the bond pair electrons will be 1, 2, 3, 4, 5, 6, 7, 8. 8 electrons, okay? Bond pair electrons will be 8 electrons. Remaining electrons will be 24 minus 8. 24 minus 8 is nothing but 16. Now you need to fill these 16 electrons here. This is what you need to do. These 16 electrons you need to fill now. Let's talk about that. How do you fill these 16 electrons? Okay. Always, firstly, side atoms is where electrons will be filled. So firstly, 1, 2, 3, 4, 5, 6, right? Then what you will have here? 1, 2, 3, 4, 5, 6, right? Then hydrogen, definitely we can't give any electron to hydrogen. It is already duplet is completed. So 1, 2, 3, 4. Can I give more electrons here? Firstly, I have only 16 and 6 into 2, 12, 13, 14, 15, 16 you have already used. Second thing is oxygen octet is already completed. 1, 2, 3, 4, 5, 6, 7, 8. Right? So valence, the remaining electrons we have already distributed very well. Right? Okay. The remaining electrons we have already distributed very well, right? Thank you so much, Kathir. Thank you so much. Thank you so much. Right? Joined. Thank you so much, ma'am. That is very, I would say, beautiful moment for me, Kathir. Right? That you have joined IIT Madras with our guidance, and nothing better than that, right? When we see that these students, when they join the session especially to tell us these things, right, to motivate us, these act as a motivational factor for us teachers as well, right? So I'm very happy for you, Katir, and all the best for your life, and I wish you do the best in IIT Madras as well. You rock there as well, right? Okay. So now tell me one thing. Everything is fine, ma'am. Then the structure should be okay. But this structure is actually not yet completed. Reason. Because this oxygen is not happy. It is having only one bond. And what about this nitrogen? Nitrogen is having only 1, 2, 3, 4, 5, 6. 6 bonds. So nitrogen is like, I don't have, my octet is not completed. So nitrogen is like, nitrogen is asking, firstly nitrogen asked this oxygen. Firstly, nitrogen asked this oxygen to help, but this oxygen was like, I have already made 2 bonds and I don't want to make the third bond. Then nitrogen asked this oxygen or this oxygen. One of them will help, right? Let's say this oxygen helped. Let's say this oxygen helped and they made a double bond, right? Now nitrogen is also happy that I have octet, my octet is completed. But now this oxygen is very sad. Oxygen like, nobody thought about me. I am not making double bond. I wanted to make double bond. So what will happen? It will have a negative charge here because it wanted to make a double bond, but it is not able to. And nitrogen will have a positive charge because it is having more than 3 bonds. So it will have a positive charge. And that is the reason this will be the structure that you have for HNO3. Yes, students, tell me if that is clear to everybody or not. Right? Okay. Right? Okay. Four bonds and else N can form only 3. Yes. Okay. Yes. Understood? So that was about Lewis dot structures. Now we are going to see the limitations, and limitations are also very important here, right? So the first part of limitation is that why there are so many compounds that Lewis dot structure is not able to draw, or it is incorrect structure that you will get. Some incorrect structure you will get if you draw by Lewis dot structure, and sometimes it is not following its own octet rule. Let's see. Now, if I draw a structure of BeF2, it actually is like this. If I draw a structure of BF3, BCl3, it is actually like this. Okay. BF3 structure, though, I have drawn it in front of you only, right? This structure, we have drawn it in front of you only, right? Now, if you see over here, beryllium is having 4 electrons in its outermost shell. Here, boron is having 1, 2, 3, 4, 5, 6 electrons in its outermost shell. So, they are not able to form octet, right? Similarly, AlCl3 will have 6 electrons, right? Now, they are not able to form the octet. So, this Lewis dot structure is based on octet rule. It is not following its own rule. So, that is why, because of this hypovalent species means where the valency is not completed. The valency, the outermost electrons are less than 8 electrons, right? So that is why, because of the existence, and it's not like these structure does not exist like that. This is a correct structure. This is a correct structure. But if you are saying that this structure is because they wanted to complete their octet, but this structure is existing, and in this structure, they are not completing their octet. So you are saying that it is because of octet rule. But because of octet rule, this is coming out to be wrong. So that means something else is there because of which they are forming bonds, right? Next is hypervalent species. Hypervalent species, for example, let me take a general example, PCl5. Actually, it exists like this. We will talk about why the shape is like this. Don't worry. Right? Now, if you see this structure, for phosphorus, tell me how many electrons will be there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Phosphorus has 10 electrons. Okay? Even if you draw SO2, even if I draw SO3, you know how many electrons it has? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Even if you draw, let's say, SF6, 1, 2, 3, 4, 5. This is what I told you. All the structures that you were asking me to draw, they are all the limitation here. Right here, the octet is not completed. Octet is extending 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it is sulfur has 12 electrons. We wanted to form only 8 electrons. It is having 12, 10. That is the reason they are called hypervalent species, which have more than expected, more than what is expected from them. They have more valence electron than that is expected from them. Okay? Got it? So this is another reason, right? This we have discussed. Next is odd electron species are very important, okay? ClO2, ClO4, these we will discuss also in P block. There are some species that has no reason why they are odd electron. It's just that they exist. Like NO, it has this odd electron, right? This is a lone pair and this is an odd electron. This is a lone pair, this is a lone pair, this is a lone pair, lone pair, lone pair, and this is an odd electron. Odd electron. This is an odd electron. Now, why there are odd electron species? Wait a minute. Okay. Yes. Why there are odd electron species, it is not able to explain. It is not able to explain why there are odd electron species, right? Then octet rule could not explain the existence of. This is one of the things that one of the students told in the starting of the lecture, that ma'am, why is xenon compounds exist? Now it is not able to explain why xenon compounds are existing, why these compounds actually exist, but how noble gases can form the compounds, right? Then it is not able to explain the existence of transition metal ions. You are saying that it should have outermost electron should be 8. Then why here in chromium 3 positive, chromium is what? Chromium is 4s1 3d5. Then in chromium 3 positive, it will be 3d4. No, it will be 3d3. Now, if you talk about the valency here, if you talk about in these terms, it has 2, 8, 11. Now, outermost should also be 8 here. Here also it should be 8. Here also it should be 8. Now, why this octet is not applied in transition metal ions? No reason behind that. You are saying it should follow octet rule. So, in transition metal, outermost never has 8 electrons. So, again, this is a question mark in this, right? So, too many limitations it had, okay? That's why this theory is a failure, right? Then, octet rule could not explain the existence of pseudo noble gas configuration. Pseudo noble gas configuration, we'll also talk about that. Pseudo noble gas configuration is, for example, zinc, okay? This is argon, 4s2, 3d10, okay? If you write it here properly, it will be 1s2, 2s2, 2p6, 3s2, 3p6, right? Then 4s2, 6 this, and 3d10. Now, zinc 3 positive. Zinc 3 positive, I'll just zinc 3 positive, if you see guys, zinc 3 positive is nothing but you have to take out 2 electrons from here, 2 positive, sorry, it will be, you will take 2 electrons from here, right? This will become zinc 2 positive. Now, pseudo noble gas, we talk about the outermost configuration. That means I'll talk about only 3 where the noble gas, let's say you have higher, first you have to find out the highest principal quantum number, that is 3. Now, in that highest principal quantum number, if the number of electrons are like in 3s plus 3p plus 3d, the number of electrons are 18. That is matching a noble gas configuration, that is argon. That means this is pseudo noble gas configuration. Now, they were unable to explain the existence of pseudo noble gas configuration. Why pseudo noble gas configuration is so stable, right? It was not able to explain it. The outermost, it is not completing its octet. It is not, it is 3d10. So, octet is not completed, but still it wants to be a pseudo noble gas. Now, he was unable to explain that, right? Then other two limitations are, octet rule could not explain the relative stability. Octet rule could not explain the relative stability and energy of molecule. Stability, energy, no talk about that. This will talk about in modern theory. Okay. This theory does not account for shape of molecule. Shape, we have never discussed about shape. This will discuss in VBT, Vesper will discuss about the shape. Right? Okay. Understood? So that's why this theory is a failure. Got it? Yes, everybody, tell me if any problem you have. Okay. Okay, yes, very good IITian. CU positive, AG positive. I'll talk about pseudo noble gas configuration because in Fajan's rule we have that. In detail we have that. Today only I am going to talk about that. Right? That's why I stopped there. So, let's talk about formal charge. Formal charge is actually, the formula is number of valence electrons in that atom where you are calculating the charge minus unshared electrons minus half of shared electrons. That is the formula. You just have to apply the formula, okay? So, firstly, you should know the structure. Structure of oxygen, we know that there is a double bond here. How do you write the structure of O3? There is a double bond here. This is oxygen. Let's say I have no idea about positive or negative charge, okay? I just know here you have 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, and this is 1, 2, 3, 4. I just know this thing, okay? I have no idea where it is positive, where it is negative. Now let's calculate. Let's say this is first, this is second, this is third. Okay? So I'll calculate the formal charge. Firstly, I'll calculate the formal charge on oxygen 1. This is the oxygen. This one is the oxygen that I am calculating formal charge on. So it is number of valence electrons of that atom. For oxygen, valence electron is 6. Number of unshared electron, that means lone pair will be subtracted. Lone pair are one lone pair. Pair no, pair is one only. Pair is one only. Pair is one. No, lone pair electrons, no, it is unshared electrons. So it will be 2 will be subtracted here because we are subtracting unpaired electrons. Unpaired electrons are 2. So we will subtract 2. Then minus half of number of, you can say minus bond pairs, or you can say half of bond pair electrons. So bond pair is 1, 2, 3, 4, 5, 6. So this is 6 minus 2 minus 3, that is 3, 4, 5, that is 1. So that's why this oxygen, that is the reason this oxygen will have plus charge. Okay, that is the reason this oxygen has plus charge, because it is coming out to be formal charge is coming out to be plus 1. Then what about the oxygen 2? What about oxygen 2? Anybody? Let's talk about oxygen 2. Oxygen 2, how many valence electron? Let's say this is oxygen 2. How many valence electrons? 6 always. How many lone pair of electrons? 1, 2, 3, 4. So it is 4. So I'll just 4 minus half of bond pair. Bond pair is 1, 2, 3, 4. So it will be 4. Okay. So answer is going to be, if you write this here, answer is going to be, I'll just do one thing here. I'll just write it here. I'll just write this one here. Okay. Easy. Right? Now, if you see this here, it is going to be 2 into 2. This is going to be 0. Right? The answer is going to be 0. So here, there, on the second atom, you have no charge. Now let's calculate the third one, that is O3. Okay, let's calculate the third one, that is O3. Let's calculate that. So for O3, how many valence? Obviously 6 for oxygen. Lone pair is 1, 2, 3, 4, 5, 6. So lone pair electrons will be 6. Minus half of bond pair. Bond pair is 2 electrons you have here. So it will be 2. So it will be minus 1. So here that's why you have minus here, right? In fact, this lone pair only is minus. So you can actually write it like this. Okay? Understood? Yes, everybody, that's how to calculate the formal charge. Right? Okay. Is that clear to everybody? Now we are going to move towards some questions, and after that we'll start with ionic bond. Okay? Yes, students? Okay. So, more the formal charge, less is the stability. So, what exactly happens here? What exactly happens? Every structure tries to minimize the formal charge by conversion of its sigma bond to double bond or triple bond. Double bond with the oxygen mainly. 3 or more than 3. See, now this double and triple bond multiplicity is only possible for period 3 or below 3, right? That we have studied in periodic table, right? Why it is so? Because in front of period 3 and in front of down the group, also in front of other group elements below period 3, they will have d block elements. They will have vacant d orbitals, right? They will have d orbitals that can be used to extend their octet. This will study more in p block, right? And that is why more the formal charge, less will be the stability. Okay, so to maintain the stability, they will try to get into double bond or triple bond. Now let's do this question, guys. Everybody here, this one is your JEE Mains 2025 question based on the limitations. If you're like, ma'am, I'll not do limitations. So this is based on the full Lewis dot structure, Lewis dot theory. So let's understand that. Firstly, molecules obeying octet rule. What are the molecules that are obeying octet rule? So we know that CCl4, CO2, these are the molecules that obey octet rule. So one is 4. Molecules with incomplete octet, that I have told you that these two are incomplete. They can also ask you, these are hypovalent, these are hypervalent, these are odd electron species, right? So here incomplete octet means second, odd electron means first. Molecules with expanded expanded octet, hypervalent, that is 3. So you'll have A4B2, 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 C1, A4B2, C1. It is only there. So answer will be C is the correct answer here. Got it? So this is your JEE Mains 2020 question. You can see for yourself, right? Okay. Right? Yes, we'll do that. Okay. Very good. Now let's move towards covalent. Let's move towards ionic bonds, where we are going to discuss about just give me a second, let me see if there is charging or not. So we are going to discuss about so many factors here. We'll discuss about Fajan's rule, we'll discuss about lattice enthalpy, Born-Haber cycle, we'll discuss about consequences of Fajan's rule, right? And so many things we are going to discuss in this, right? So everybody ready? So shall I give you break of 5 minutes, right? Okay, shall I give you 5 minutes break so that your mind also can be refreshed? Okay, yes, everybody. Okay, so I'll give you break for 5 minutes, or you want break for 10 minutes, I can give you accordingly. No, I just saw your thing. I know that break is important, right? Okay. Yes, Adirit. Okay. So 5 minutes or 10 minutes, tell me that in the chat box. Right, I'll just give you break, and after break, because new concept we are going to start. This chapter is very big. Completing this in 4 days is a task, right? Break for 10 minutes or 5 minutes. I think 1 hour more it will take to complete ionic bond, because small topics you have, right? But from lattice enthalpy, from Fajan's rule, and from these 2 topics, the questions are asked. Okay, so that's why we can't miss it. Usually students miss these things. 15 minutes will be 2 minutes, will be too much. I think 5 minutes is enough. Okay, so I'll see you all at, okay, and I'll see you all at 10:05 p.m. right? Okay, so I'll see you all. Till then, take care. Hello everyone. So welcome back. Let's resume the session. Ma'am is also back. Definitely ma'am is back. Okay. Okay, let's see this, okay? Yes, everyone, let's see. Let's talk about ionic or covalent bond. So if you talk about ionic bond, it is because of transfer of electrons, right? So bond formed as a result of electrostatic interactions, attraction between positive and negative ions. That means a cation and an anion is going to form a bond, right? Now this cation will have some charge, this anion will have some charge, and this electrostatic force of attraction, right, when it is formed. Now why this is losing electron to complete the octet, okay? This is, if you see this, this is 2 8 1. If it loses one electron, it will become 2 and 8. If this gains one electron, it will become 2 8 and 8. So because of that, it is losing, it is becoming a cation, and this is gaining, and this is becoming an anion. And after that, there will be attractions between this cation and anion, right? And that is nothing but that is your ionic bond, okay? That is your ionic bond. Now, in ionic bond, right, we are discussing about ionic bond. But as I told you, there is cation, there is an ion, and because of that, there is force of attraction. Now, when you talk about, ma'am, what are the factors on which this will depend? Let's understand that. First is very large electronegativity difference. More the electron, this we have discussed in periodic classification also. More the electronegativity difference, when we discuss about electron negativity, we discuss about this point. More the electronegativity difference, more will be the more stronger will be the bond, and that is the reason more will be the bond energy that is required to break it. So more stronger will be the ionic bond, right? Second is low ionization, very important. Now when the sodium is losing electron, energy will be required to take that electron out. Energy is required. I have to give energy to take that electron out, right? So if ionization energy is low, then easily is like, okay, you can take electron. I am fine. I am happy. You take electron from me. So that means I need to have low ionization energy if I want that atom to become a cation. So low ionization energy for electropositive element, that means the one that wants to lose the electron, should have low ionization enthalpy, right? The one that wants to lose the electron should have low ionization enthalpy. Clear? Next is electron affinity should be high. Now next is electron affinity should be high. If I am talking about electron affinity should be high, ma'am, why so? Now understand one thing. In all the cases where we are writing electron affinity should be high means it should go crazy. It will be like, I want to eat this dosa, I want to eat this, I want to eat this burger, I want to eat this pizza, right? If your electron affinity, your power to gain that is very high, that means, can I write this in simple terms? Can I also write this as that its electron gain enthalpy will be highly negative. If it is like, I want to gain the electron, my electron affinity is positive, so its electron gain enthalpy will be very high. It will happily give happiness, right? It will release energy. More energy is released, more stable will be that ionic compound. So that means high electron affinity means the release of energy, right? that should be high after gaining the electron. Okay, this concept of electron affinity and electron gain enthalpy I have told you in periodic classification. Last is high lattice enthalpy, that we will learn. That is still a question mark. Okay, we'll learn about that. Firstly, based on first 3 points, let's discuss. Okay, firstly, based on first 3 points, we'll discuss some questions here. Right, I'll just write 2 questions: NAF, NaCl, NaBr and NaI. Second question is NaCl, then KCl, then RbCl. They are asking you which is strength of ionic bond. Strength of ionic bond you have to tell in these 2 things, right? So how you will tell? See, always remember along the period, this is a a very important point for you. Along the period, size change is very less, right? So along the period you will talk about charge, but instead not here. Let's talk about ionization enthalpy here. Here we will not talk about that. So here what we will talk about, here F, this is Cl, the difference point is this is Br, this is I. Anion is different. And for the electron negative element, we discussed that high ionization, high electron affinity should be there. We know that down the group size increases. So electron affinity, down the group electron affinity, if I say size is increasing, electron affinity is decreasing. If electron affinity is decreasing down the group, its ionic character will also decrease. Okay? Because we have understood this thing that more the electron affinity, more will be the ionic character. Okay? Second is what we have. Second is, guys, we have NaCl, KCl and RbCl. Can you see this here? What is the differentiating point? Sodium, potassium and rubidium. Cation, this is for anion. For anion we discuss electron affinity. For cation, what we are going to discuss? Anybody? For cation, what we are going to discuss? For cation, what we are going to discuss? For cation, we are going to discuss which part? We are going to discuss ionization enthalpy. Okay? For cation, we are going to discuss the ionization enthalpy. Low ionization enthalpy will be more happy, right? So low ionization, we know that down the group what is happening again, guys? Down the group again, guys, what is happening? Everybody, size is, ma'am, increasing, ma'am. Ionization enthalpy, ma'am, it is decreasing. So sodium has maximum ionization enthalpy. That means it will be least ionic. More ionization, less ionization enthalpy means more ionic. Because you require low ionization. Directly, I'll just write one thing here. Ionic bond strength is directly proportional to electron affinity inversely to ionization enthalpy. As simple as that. As simple as that. Okay? Just remember this thing. If they ask you directly the ionization enthalpy. Okay? Right? Got it? Will you be able to answer directly ionization enthalpies if they ask you? Right? Okay. Just remember this thing. If they ask you directly the ionization enthalpy. Okay? Right? Got it? Will you be able to answer directly ionization enthalpy? How much more loudly, guys, you need? Right? How much more loudly? Huh? So now, next is At such a young age, you have hearing problem issues kya? BTS fangirl? So now we have discussed about these three steps: ionization enthalpy, electron affinity, electron negativity. What about this lattice energy, ma'am? What about this lattice energy, ma'am? Okay, so let's understand that. Before lattice energy, I have one question for you that I want to teach you, right? This is based on electron negativity, okay? This is your JEE 2024 question. Can you see that? Based on the simple factors, they are asking you question in JEE 2024. Then you say, ma'am, please ma'am, difficult ma'am, paper was very difficult ma'am. Based on the simple thing, they have asked you a question. Arrange the bonds in order of increasing ionic character. Now more is the electronic. See, here cations are different, anions are different, so that theory will not be applied. Lattice energy theory also we won't be able to apply here, that I'll tell you why. So that means it is based on electronegativity. More the difference, more will be the ionic character. So we know that this belongs to group 1, this belongs to group 17, so this will have maximum. So this is eliminated, this is eliminated. N2 should have minimum. Yes. Why? Because it is N and N, same, no electronegativity difference, so directly answer is A. In seconds we have answered, right? Maximum, minimum we knew and nothing else you need to worry about, isn't it? So answer is A. Yes ma'am, it is the correct answer. So 2024 question, have we answered it in seconds? Right? Have we answered it in seconds? So was it a tough question? Not at all. Was it an easy question? Yes. Was it an easy question? Yes. Okay. And before starting lattice enthalpy, let's see how many likes you have made. Let's see that. Let's see that. Only 32 likes. Not fair, yeah, not fair. Those who are watching this on the recorded version, if you like these kind of sessions, then do like those hit that smash button, hit that like button. Hit that smash button, smash that like button, hit that like button, right? So that I can also get to know that you guys actually like the content that we give you, right? Okay. Okay. I have pre at which 50 marks, so thanks for teaching chemical bonding. Most welcome, most welcome. Now, let's talk about, I didn't get the answer, guys. Okay. Based on electronegativity, we are answering this. This has maximum difference, so it is maximum ionic character. This N and N has no difference in electronegativity, so it will have least ionic character. So that's why answer is A. Okay, that's why answer is A. Got it? Good, 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 everybody. Now let's talk about lattice energy. Lattice energy is, I am talking about either to make 1 mole of ionic compound from its gaseous state. So, if I talk about, you have Na cation in gaseous state, you have Cl anion in the gaseous state, and you are making NaCl, right? And this energy required is called lattice energy. Here the energy will be released, here the energy will be released. Lattice energy will be negative because whenever two ions are getting attracted with each other, they are forming a ionic compound, they are very happy, so they will release the energy. So in this case, what will happen? Energy will be released. Energy will be released. Now let's talk about the reverse of this. When you break an ionic compound into its ionic gaseous state, their lattice energy is required. Okay, so both the definitions are correct, right? In some books you will see this definition, in some books you will see that definition. Here we have written ionic compound, lattice energy, if you are breaking it, ionic energy required to separate 1 mole of solid ionic compound into its gaseous ions. That is called energy will be required. But when you form an ionic compound, right, from its ionic gaseous state, that energy will be released. So here energy is released and here energy is required. Here energy is required. Tell me if that is clear. That is clear to everybody. Energy is released also and required also, right? Okay, Anjali, Suhas, Adhirit, BTS. Clear? Shall I move ahead? Lattice energy definition is clear. Some students, ma'am, is it required? Is it released? It is both. It depends upon which thing you are talking about. Now, lattice energy, lattice looks like this. Can you see the lattice actually looks like this? Can you see this lattice here? Can you see in solid state for JEE Advanced when you will study solid state. Earlier that was in JEE Mains also, but now it is not there. This is one cube, right? So one cube is one unit cell. So many unit cells are making one lattice, right? And these ionic compounds exist as lattice, where these green and red balls that you can see, these are the atoms, right? So it's not like one NaCl and one Cl are making a bond. It is not like that in ionic compound. They have a lattice structure where if you have Na is 100, then chlorine will also be 100. That's why the structure is NaCl, right? If sodium is 200 and Cl is 100, if they would have this much in one lattice, then it would have been Na2Cl, right? That's how you have NaCl, right? So that is the lattice. So to break this lattice, the energy that is required, that is called lattice energy. So this is how it actually looks like. When we talk about lattice, it actually looks like this, but we know that chlorine has bigger size as compared to sodium. So that is the reason it will look like this. These green are chlorine atoms, these red are sodium atoms, okay? Now, what is Born-Haber cycle? To measure the lattice energy, we use a cycle that is called Born-Haber cycle, right? So what kind of cycle it is? Let's talk about, right? Is it a Hero Honda cycle? No. So what kind of cycle it is? Let's make sodium chloride, okay? So tell me, sodium exists as solid, chlorine exists as gas. When you form NaCl, you will have, when you form, this is a definition from thermodynamics. You must have heard about this definition from thermodynamics, that heat of formation is when you form 1 mole of a compound from its elemental state. Now the elemental state of sodium is sodium solid. Elemental state of chlorine is chlorine gaseous. So this is actually delta H formation. Formation in the formation. This is delta H formation, right? Now let's make this cycle. Lattice enthalpy, we need to have sodium in cationic form in the gaseous state. So firstly, I'll convert it into the gaseous state. No, firstly I'll convert it into the gaseous state. Yes. Sodium, I'm converted into the gaseous state. Now if you see this here, into the gaseous state, there is sublimation. So can I say here you will have delta H of sublimation from solid to gas, right? Then what we will have here next? We need to convert it into its ionic state. So it will be sodium positive gaseous. Whenever it loses electron, we have ionization enthalpy. So I'll write here ionization enthalpy or energy, that is IE, right? Okay. In this case, for chlorine, what you will have? You'll have to firstly dissociate it. You'll have to firstly convert it into one atom, because there are two atoms. It is chlorine and chlorine. You need to have one atom only, right? So firstly, what you will do? Make it into chlorine gaseous. That we require bond dissociation energy, right? Bond dissociation energy is required. Then to convert this into ionic state, you need to give it some electron, right? When an atom gains the electron, then electron affinity is what we talk about, right? Okay, this is also in some books, na, in good books, it is represented as delta Heg to gain the electrons, because electron affinity and electron gain enthalpy are always opposite. Okay, and after that, when these two are added, they are in their gaseous state. Then when you make the compound, here, that is called as lattice energy. Lattice energy. Okay, and this lattice energy is what we are talking about. Now let's see which is positive, which is negative. If we talk about sublimation, always energy is required, so it is positive. Ionization also energy will be required. Bond dissociation also energy will be required. Now talk about electron affinity. Electron affinity is only the capability, right? If it wants to gain the electron affinity will be positive, but the energy that is in form of electron affinity is only the capability. It's positive or not, that tells us the tendency for it to gain or not gain the electron. But if you talk about in terms of energy, we talk about electron gain enthalpy, which will be negative. Because after gaining one electron, it will become, octet will be completed, so it will be happy. Halogen after gaining one electrons are happy. So they will gain electrons very easily, right? And this whole cycle that you see here, this full cycle, that is called as, this full cycle, guys, that you can see here, this full cycle here, that is called as Born-Haber cycle. Got it? That is called as Born-Haber cycle. Got it or not? Tell me if there is any problem in this. Okay? Any problem? Yes. Any problem here? Is that clear? Shall I move ahead? Now everything else is just simple calculations. If you see this here, these are simple calculations. We are saying that from this solid to gas sublimation, bond dissociation energy, ionization energy that is required. This is electron gain enthalpy, that is negative. So you can see all are positive, electron gain enthalpy is negative, right? And lattice energy will add here, right? And this will become your overall, this is nothing, they have given delta H formation from solid and gas, then converted into NaCl, that is your delta H formation from the elemental state. So now they are saying that if you know sublimation, bond association, ionization, electron gain enthalpy and delta H formation, you will easily be able to answer the lattice energy from here. Okay, only one term is missing, that is lattice energy. You can easily answer it. This is what they have given you here. The calculation part is given here. So that's how you can calculate the lattice energy from the Born-Haber cycle. Okay, got it? Yes, everybody. Now let's understand the, my throat is paining a little bit now, so I'll have to take some medicine. So For two ions, with charges Q1 and Q2, I told you earlier also, two ions are there, cation and ion, they will have charges. So we know that electrostatic interactions, we have discussed this in physics, it is directly proportional to, you can also write it as this K Q1 Q2 by R, okay, or you can just directly write it is directly proportional to this is R square, okay. That is the this is actually they are talking about energy, force also you can talk about, right? So we know that definitely from this we can say that this lattice energy is directly proportional to charge and inversely to the size, and this is what we need to take from physics, okay. So we can say lattice energy is directly proportional to size, no, charge. It is directly proportional to the charge and inversely to the size. Now I know that here you're like, okay ma'am, but you need to also discuss some questions based on this. Let's do that, okay. First is NaCl, MgCl2, AlCl3. Let's discuss this. Now NaCl, MgCl2, AlCl3, the difference is that it has Na positive, it has Mg2 positive, it has Al3 positive. So definitely along the period, now I'm giving you this tip here, along the period always go for charge. 99.9% you will see charge. Down the group, because the charge is same, so you will see size, okay. This is very important, okay. This I'll just copy paste, not here, rather I'll just I'm marking this here so that you remember this, right? Okay, this is also a very important thing, right? Now you will be able to answer things very easily, right? Now this is along the period. See the charge. Charge is directly proportional, so it will be this lattice energy. This will be, we are talking about, we are solving the lattice energy. Okay. Now let's talk about NaCl and KCl. NaCl and KCl, it is down the group. Down the group, always see the size. Size of potassium is greater, so that is the reason, because size is inversely proportional to lattice enthalpy. So NaCl will have greater lattice enthalpy. Okay. Here we can see the charge. Here we can see the size. Okay. Next is, let's talk about NaF, NaCl and NaBr. The differentiating part is down the group. It is fluorine, chlorine, bromine. That means along the group, what I told you, you should focus on size or you should focus on the charge. You should focus on the size here. Down the group, focus on the size, and that is why more the size, less is the lattice enthalpy. So answer will be this, right? Okay. Last one, let me see who will tell me. LiO2 and Li3N. Yes. Who will tell me the last one? Last one, let me see who will answer. Let me see that. Let me see who will answer. I'm busy in your own talks. Let me see who will answer. Difference is, this is O. Wait a minute, this will be Li2O. Okay. This is O2 negative, this is N3 negative. It is along the period. Along the period, we always see the charge. It's negative or positive, doesn't matter. More the charge, more will be the lattice enthalpy. So, got it? Very good. Now I'll give you a question that will confuse you. That's my duty, to give you questions that will confuse you, right? So tell me that. Now I'll solve it, don't worry. I know, because let's see what is the problem firstly. Cation is different. Here it is sodium. Here it is Mg2 positive. So here you should see the charge. Whenever you're going along the period, you will see the charge. But in case of an ion, it is F negative and Cl negative. This is along the group. So you will see the size. So when you see it according to charge, right? When you see it according to charge, because here charge of Mg is greater, so that means MgCl2 should have more lattice enthalpy. According to size, chlorine has greater size or less size? Greater size, right? So greater size should have less enthalpy. So it should be like this. Now two answers we can have. Based on charge, you are getting a different answer. Based on size, you are getting a different answer. So what you will adopt here? So always remember, make it DM. DM means Diksha Ma'am, right? Oh. Where we were? Wait a minute. Yes. Okay. Make it charge dominates if both are present. If you have both the things, then charge will always dominate, right? So correct answer will be so MgCl2, or you can say NaF is less than MgCl2 because of the charge. This answer is based on only the charge, nothing else, only based on the charge. Got it, everybody? Right? So this we have done. Now let's discuss Fajan's rule. That is the last rule that we have, last thing that we are going to do in today's class, right? Okay, ready for the last topic of today's class, guys? Everyone, are you ready for the last topic of today's class? Anjali, Suhas, Frock, BTS, Avidut. Guys, focus. Okay, ready for the last topic? If yes, then spam the chat box with green hearts, guys. It's almost 10:40. It's 10:40 and still here to teach you, right? Do you understand? We are sacrificing our personal life for you guys, right? So you need to appreciate us for that, right? So spam the chat box with green hearts, okay? Yes, everybody? Very good. Green hearts, I can't see. Thank you so much. Thank you. So what you can do for me now, you can just share this session with your juniors, right? With your friends also. With your seniors, I really doubt that, right? Because your seniors will be in maybe IITs, right? So yes, if there is any dropper, you can share this with them, right? Okay, yes, these are the green hearts that I want to see, right? These are the green hearts that I'm looking for, right? Yes, very good, Adirit, Anjali, Suhas. Don't do conjusi in giving me green hearts, okay? That makes my day. That makes me happy, right? And that motivates me. I'm speaking only with the help of this medicine. So I'm done now taking allopathy. So I'm trying Ayurveda now. So let's see if it works or not. So it's not easy to teach you for these. It's been 3 hours, okay, I'm teaching you. Let's see. Let's understand covalent character in ionic bond. That is Fajan's rule. Let's understand that. So Fajan's rule is based on this thing. Okay. So in a ionic compound, you have cation, you have anion, right? Now what exactly happens here? This cation, if I say this is the cation, wait a minute. If I say this is the cation that we have, this is the cation that we have, right? This has positive charge, this has positive charge, right? And this is the anion that we have. This is the anion that we have that has negative charge. So this anion will have negative charge. Okay, this anion will have negative charge. So what will happen exactly? This was not earlier like this. So firstly, you had a cation here. You had a cation which is always smaller in size as compared to anion. This is the anion. So because of electrostatic attractions, they formed electrostatic bond. Now this electrons, the electrons that are present in the anion, they are getting attracted by the cation because it is positive. And because of that attraction, what will happen? This polarizing power of cation, polarizing power means to pull the electron cloud towards itself. Polarizing power of cation. Cation be like, I want to pull these electrons towards myself. So it is pulling these electrons, and because of that you have this kind of situation where these electron clouds are pulled towards the cations, right? Where these electron clouds are pulled towards cations, because these electron clouds are pulled towards these cations. Now what will happen? There will be these electron clouds will get penetrated into cation, and there will be slight covalent character that you will observe here. So what you will observe? A covalent character. So that's why it is called covalent character in ionic bond. So covalent character you will observe in the ionic bond, right? It is dependent upon so many factors. Let's discuss about it. Is dependent upon size of cation, anion, charge on cation and charge on anion. So cation has polarizing power and anion has polarizability. Polarizability. Okay. So when cation is very small, cation is very small, cation is very small. So less, if the size of the cation is very small, its power to attract the electrons of an ion towards itself will be more. Because in a very less size, in a very small size, the let's say two things. This is a charge which has +1. This is a charge, this is a cation which has +1. Which will have more polarizing power? Because in smaller size, the positivity is in a very dense area, right? In a larger size, see, simple thing is, if you live in a very small house, right, what your parents are talking, right, you'll have to, when you're talking to your friend, you'll have to tell your parents that please don't fight today, I'm talking to my friend, right? You're talking to your teacher and you're telling your parents, please don't fight today, I'm talking to my, this always happens with me. When I'm taking the class, no, sometimes they will start fighting and I have to tell them, please stop fighting. You guys are on YouTube, your fight is on YouTube, please stop fighting, right? So when the house is very small, you can hear each other things, what they are talking. But when the house is very big, you can't hear. So the persons who are there living in the house are distributed in a very large area, right? So the power of pulling will be less. So that's why smaller the size, more is the polarizing power. Bigger the size of an ion. If an ion is big, this is a smaller anion, this is a smaller anion, this is a bigger anion. So bigger is the anion. So see one thing. You're living in a small house and someone is coming out there and telling you, go out. You guys are so happy with each other, right? You're living with your parents, you guys are like really fond of each other, so happy together, you don't need to go out, you're very happy. But if you're living in a very big houses like Anant Ambani, all these people live in very big houses, they're not even interacting with each other, right? So they are pulled towards outer atmosphere more, right? Because the interaction with each other is very less. So they are like, oh my god, this is my friend, I'll go to his place, because they are not interacting with their own siblings. We are sleeping in one room with our siblings, right? Some people are also sleeping in one room with their parents, right? I used to do that, right? So our bond with our parents, with our siblings is so strong, we will not go out and make new people our best buddies. Like family is the best. But when you're so away from your family, you're not that much close to your family, you will want to make new bonds, right? So that's why when the anion size is bigger, the electrons polarizability will be more. The electron want to go out. They're like, okay, cation is attracting me, I'll go out, right? So that's why more the size of an ion, more will be the polarizability of an ion. And charge, it is directly proportional to, if charge on cation is greater, more will be the polarizing power. If charge on anion is greater, more will be the polarizability, right? So you can write it here. Simple thing is, covalent character is directly proportional to, everything is directly proportional. Charge on cation or anion, it is directly proportional. Size of an ion, it is directly proportional. But size of cation, it is inversely proportional. Okay? Understood? Now, let's talk about pseudo noble gas configuration. Now, Fajan's rule state that all the elements which are forming pseudo noble gas configuration, they will be more stable. They will have more covalent character. Pseudo noble gas configuration means covalent character will be more. Okay, pseudo noble gas configuration means covalent character will be more. How do you define and what is pseudo noble gas configuration? Let's talk about this example here. For example, you have Cu positive, copper. Copper is what? 1s2, 2s2, 2p6, 3s2, 3p6, 4s1, 3d10. What is copper positive? Students, what is copper positive? What is copper positive? Copper positive is nothing but you take out electrons from this 4s and that will become copper positive, right? Now, can you see in the outermost how many electrons you have? 10 plus 6 plus 2, the electrons are 18. So it has noble gas configuration and this is called pseudo noble gas, right? Now let's talk about sodium. 1s2, 2s2, 2p6, 3s1. You take out 1 electron from sodium, you take out 1 electron from sodium, you will have this configuration. Now tell me, in the outermost, how many electrons are there? In 2, you have how many electrons? 6 plus 2, that is 8. Is 8 any noble gas configuration? Is 8 the atomic number of any noble gas configuration? No. So this is not a pseudo noble gas. This is a pseudo noble gas. Okay? Okay, guys. Now I'll just write down all the elements which shows noble gas, pseudo noble gas configuration. Zn2 positive. Cadmium also shows. Mercury also shows. Ag also shows. Au also shows. Then Cu also shows. So these are the elements which shows pseudo noble gas configuration. These are the elements that you can see will show pseudo noble gas configuration. These elements: zinc, cadmium, mercury, gold, copper and silver. Okay, zinc, cadmium, mercury. Okay, this is what you do mistake now. Anjali is saying, ma'am, this is also, ma'am, configuration of neon. We are not saying that the configuration should be noble gas. We are saying the outermost electrons should be same as the number of electrons in a noble gas. So here the outermost electrons are 18. Here the outermost electrons are only 8. So we are talking about the outermost electrons. We are not talking about the noble gas, the configuration. That's why I have shown you sodium also. That is the reason I gave you an example of sodium also, because I know that you can do mistake here, right? Okay, got it? We are talking about the number of electrons in the outermost should be same as noble gas. So now we will solve some questions here. I'll just give you some questions, 2-3 questions only, right? That is NaCl, MgCl2, then you have NaCl, you have AgCl, then you have BeCl2, MgCl2, CaCl2. I think till now you are pro at this. Here sodium and magnesium is different. I told you, always when charge and size is the comparison. Same thing that we did for lattice energy. When charge and size is the comparison, which criteria to choose? Along the period, choose charge. So more the charge on the cation, more will be the covalent character. So here we are solving the covalent character. So this is based on charge. Now out of Na and Ag, which is your pseudo noble gas? Ag. So that is why this is based on pseudo. With the one which has pseudo noble gas configuration will be more stable, right? More covalent. Here you have beryllium 2 positive, magnesium 2 positive, calcium 2 positive. That is down the group. Down the group you always choose what? You always choose size. Size of cation is inversely proportional. If it would have been an ion, it would be directly proportional. Because here it is cation, it is inversely proportional. So more the size, less is the covalent character. So answer will be this one. Okay? Got it, everybody? If this would have been the size of an ion, then that would have been directly proportional. Okay, right? Got it? Good. So, you know what? I have big question that are you able to understand what I'm saying? So, I'll just write it here. NaF, NaBr. This is also down the group, but here we are talking about size of an ion. Here we are talking about size of anion. This was size of cation. When you talk about size of anion, in case of size of anion, more the size, more is the covalent character. Okay, this is what I want to tell you when I talk about size, right? Now, I think that's it. Now we will do the consequences of covalent character. Consequences, what are the consequences of covalent character? Can you hear the barking of the dogs? The dogs are like, ma'am, please leave the students, ma'am. They want to sleep, ma'am. Please leave the students, ma'am. Okay. So here it is solubility. Then the next factor is melting and boiling point. And the third factor is color impartation. So more is the covalent character, less will be the solubility, less will be the melting and boiling point, and more will be the color impartation. That means, can I say, covalent character is directly proportional to color, inversely to solubility, and inversely to melting and boiling point. Okay. Clear, everyone? Clear. Okay, done. Done. Yes. After this, let's talk about this thing. Let's solve some questions here. You have to tell me the color here. Okay, you need to tell me the color which will have more dark color, which will have more color. More color means more dark color which will have. PbCl2 and PbI2. It is directly to covalent character. Chlorine and iodine, it is the down the group. You have one is chlorine, one is iodine. Down the group, always we talk about size. More the size, more is the covalent character. So covalent character is in this way. So color will also directly proportional to that. So the color of PbCl2 will be, that is why it is colorless, and that is why PbI2, it has dark yellow color. Dark yellow color. Now very famous compound I am going to write. You have AgCl, AgBr, AgI. Now don't tell me, ma'am, please, ma'am, Ag is a pseudo noble gas configuration. If AgI compare with something which is not pseudo noble gas, then it would be greater. Now Ag is common in all of them. So we'll compare Cl, Br and I. More is the size of anion, more is the covalent character. So covalent character will be like this. And that is the reason more is the size, more is the covalent character that we have seen. So color will also be in the same range, right? That is why here this is of white color, this is of pale yellow. Let me just find out if I can find a pale yellow color. Pale yellow, and this is dark yellow, bright yellow. Okay. I just got scared. Okay, got it? So one more question. If they ask you, let's say they are asking you solubility or melting boiling point. And the question is KCl and CuCl. KCl and CuCl. Tell me which one will have more solubility, KCl and CuCl. Everybody, KCl and CuCl. Simple thing is, in KCl and CuCl, we know that covalent character will be this way. So solubility or melting point or boiling point will be opposite to that. So it will be KCl greater than CuCl, and that is going to be the answer. Okay, everybody? Very good. Very good, very good, very good. Now let's do the last question of today's class. Last question of today's class. Let's see that. Arrange the following in increasing order of their covalent character. 2022 they have asked this question. Can you see? Then ma'am, we ignore ma'am Fajan's rule, lattice, everything you ignore, and this is where they ask you the questions. Okay, so JEE means question 2022, following increases the order of covalent character. So you need to tell me the order of covalent character. Yes, everybody, in the chat box, tell me. Yes, guys, I'm waiting for your answers. This, you can answer this easily. Anjali, Aitian, Suhas. Last question, let's see who will answer. Simila. Yes, everybody. Increasing order of covalent character. So we know that calcium is same. The difference is fluorine, chlorine, bromine, iodine. So it is directly proportional to the size of an ion. So more is the size of an ion, more will be the covalent character. So this will have maximum covalent character. So answer will be, acha, they have asked you to write it in the order, okay. So order will be D is maximum, right? Obviously it is going to be firstly D, then C, then B, then A. So it will be A, B, C, D. A, B, C, D. So answer will be B is the correct answer. Okay? Got it? And that's it for today. Now this is your homework, everybody. Write it down. The homework is, in which of the following molecules each combining atom does not acquire 8 valence electron. 8 valence electron it does not acquire. Right, this is the first homework. Next is, which of the following is not pseudo noble gas? This is the second question, everybody. Which of the following is pseudo noble gas? Second question. Take the screenshot here. Take the screenshot. Okay. Take the screenshot here also. Ma'am is blurry. Yes. Take the screenshot. Yes. Done. Okay, so I'll be waiting for your answers in the comment section. And before going, today's lecture we have completed, and yes, in the next class, that is tomorrow, we are going to start with Vesper and VBT, right? Vesper will complete, VBT will start in the next class, right? So Vesper and VBT is the next lecture, right? And guys, let's talk about MVSAT. Now MVSAT is Megha Vedantu Scholarship Admission Test. The registration is absolutely free of cost. You just have to register yourself and then give the test on 4th, 5th, 11th and 12th of October 2025. Just 1 month left. And what you will get here. First thing is, you will, if you get into AIR among 2.5 lakh students, you will get scholarship worth 150 crores. That means 100% off on all the courses, and 2 crore worth crash prizes and rewards that you will get, right? So you're already preparing for this. One-on-one counseling, study material, free courses, all these will eventually be free to you, right? So it's like a jackpot that you will get here. For that, you just need to register yourself. The link is in the description. Do that. And already you are preparing for JEE, right? So there is, yes, one more thing. Online also you can give MVSAT program, right? If your Vedantu center is very far away. but I would advise you to actually go in the center and then give your test, because then more benefits you will get from there, right? And that's it for today, students. The link is in the description for MBSAT and hashtag chemical bonding started. Okay, so write it down if you're happy that we have started chemical bonding in the comment section, and those who are watching this on the recorded version as well, I would love to see your comments in the comment section. And guys, for you it may be just, okay ma'am, how does it matter if we comment or not, how does it matter if we like or not? You have no idea how much it matters to me, right? It matters the world to me. That is why I'm here, I'm teaching you, because it feels good when we see your paragraphs, your what, even our ex students and the students who are in this right now, whom we are able to we are able to teach them, and they are able to understand things, right? If because of us they are able to do that, so we'd love to hear it also. This makes our day, right? So I would love to see your comments in the comment section, right? Okay. Yes, Sukesh. Okay, yes, Sukesh, got it. So, okay then. Bye bye, guys. Bye bye. Bye bye, Sukesh, Suhas, Anjali, and Tuhi. Then Unseen. Yeah, rest of the students are sleepy, I guess. Okay then, bye bye. Take care. Now see you all in the next class. Till then, bye bye. And please do your homework that I have given you here. This is the second question and this is the first question. Okay, this one is the first question, right? And this one is the second question. So please do your homework. I would love to see your homework also in the comment section. Till then, bye bye. Take care. See you all in the next class, that is tomorrow at 8 p.m. Bye bye.